So, my name is Nitin Tomar. I am a third year PhD student in the Department of Mathematics at IIT Bombay. I welcome you all to this live session regarding the doubts of the complex analysis. So, I hope my screen is visible.
Yes.
So, can you mute yourself? And if you have some doubt, then you can unmute. Okay. Yeah. So, the question one is, so this time I'm going to try a different approach. Instead of having the solutions ready, I'm going to discuss solutions with you and I'll write here. Okay. So it's assignment 6 from MA57 previous year session. So it is an MSQ part, multiple select question. So I will discuss each part one by one. So the first part is if gamma 1 is the unit circle, if gamma 1 is the unit circle centered at 10, centered at 10, and gamma 2 is again the unit circle centered at 0, then gamma 1 and gamma 2 are homotopic. Gamma 1 and gamma 2 are homotopic. So Darshan, do you know like what do we mean by homotopic? Two curves being homotopic?
Uh, Two
Two
curves are
curves are
homotopy if
homotopy from uh,
there
there
exists a
exists a
function
function
HST
HST
Yes, exactly.
from
from
zero
zero
1
one
cross
cross
AB
AB
to
to
omega.
omega.
Exactly. So
So
in this case, if there is a homotopy, what do you think? What should be the answer?
answer
Answer
is
is
yes,
yes,
gamma 1
gamma
and
1 and
gamma 2
gamma
are
2 are
homotopic.
homotopic.
Yes. Okay. So this is our intuition, right? Okay. They are of same size. So you can always mute yourself. Okay. When I mean because otherwise it we have an echo. Okay. So let's say this is gamma 1 and this is gamma 2. Then what should be the function? You can just take 1 minus s gamma 1 t plus s gamma 2 t, where h is from 0 1 cross 0 1 to c. And you see when you put h 0 1 you 0 t, you'll be having gamma 1 t, right? And if you're having h 1 t, then it is gamma 2 t, right? Is it clear? Oh, is it visible first of all?
Yes,
Yes,
sir.
sir.
Are you sure?
Yes.
Okay. Thangeshwaran, you are late today. What happened? Okay. So can you see like what does this map do? So it's like if you look very closely, then this map is translating gamma 2 on into the direction of gamma 1, right? Can you have this feel from this map what we are defining? So gamma 2 is fixed, right? Gamma 1 is fixed. So it's like at time s equal to 0, s denotes the time in some sense. When you're at s is equal to 0, it is gamma 1. Okay, sorry. When s is equal to 0, we have gamma 1, right?
Yes.
Yes. And when s equal to 1, we have gamma 2. So it's
Two.
like in between, this curve is like, like this curve is flowing like this. And finally, it goes to gamma 2. Is this clear? Like, this is something I want you to realize what is happening.
Yes.
Yes,
Yes.
yes,
So
Yes, sir.
imagine gamma 1 running towards gamma 2, because they are of same, I mean, it's easy because they are of same size, right? So is this question clear?
Yes, sir.
yes, sir.
Okay. So this option is true. Now the question is, if gamma is a curve in C, then gamma plus minus gamma is null homotopic. Is null homotopic. So we know what do we mean by null homotopic, right? We know what do we mean by two curves being homotopic. If one of them is the constant curve, then we say that these two curves are null homotopic if either of them is a constant curve, right? Okay. So what does, so if you have some curve, let's say gamma here, if this is your curve gamma, oh, okay. So let's say this is my gamma, or should I? So this is my curve gamma, okay. So now what will be minus gamma? So if gamma is in this direction, so minus gamma, if this is gamma, okay.
Opposite
Opposite
direction.
direction.
Exactly. Thank you both of you. So minus gamma will be, so this direction, right? So this is clear, right? So let this point be z naught. So isn't it null homotopic to z naught? Because at z naught you are having a closed curve, right? I mean, in this case, this is not like this, but you can imagine like this. So this will be null homotopic to this, right? So this is also a part of the theory that you must have learned. Hello. See, gamma is a curve starting at z naught and ending at somewhere, and then it takes a turn back, and it comes back to z naught. So what do you feel like? What is the actual behavior of gamma? It's a closed curve, right? First of all,
Yes,
Yes,
sir.
sir.
Close
Close.
curve.
yes. So it's a closed curve, and not only that, it's a closed curve. It's tracing back its trajectory. So can you construct a map like H? So for example, you can, if not, then you can use this map only, right? H of st is 1 minus s. So let this be gamma 1, okay? Gamma 1 t plus s z naught. Now what is s0 t? S0 t is gamma 1 t, right? because we are in C is a convex domain, right? So everything is well defined. And what is h1 of t? Can anyone tell me? Hello. So what is
Z
h
naught.
z naught? Yes. And not only that, hs of 0. So when do we say? So you must have seen some lecture notes. Okay, so I am opening the lecture notes. So when do we say a path is null homotopic? A curve is null homotopic? So a curve is null. So I don't think it is clear. Yeah. So if these two condition holds, h of 0t is equal to gamma naught t, and h1 of t is gamma 1t, and hsa is hsb for all s. So let's check our hsa. Where was it? Yeah. What is hsa? It is gamma 1a plus sa. Just a minute. I These things you should try actually. Actually,
सर दिस इज फॉर क्लोज्ड होमोटॉपिक क्लोज्ड कर्व के लिए ना होमोटॉपिक.
no, I am saying about the null homotopic. I think just
यस.
yeah.
सो नॉन हाइपोटॉपिक में अलग है.
Hmm. So you have seen these lecture notes, right? Hello.
यस
Yes,
सर.
sir.
Yeah. So this is the definition. Can you see the definition? Okay. What you do? You try this question on your own. We have done the first part. Okay. And if you have some doubt, then you just write it to me. Okay. But like first of all, the intention should be clear. You know why this answer should be a yes. Are you getting my point? Like, because see, the gamma starts at z node, some point. You just assume some point, and then it takes a turn back. It retraces its trajectory. Okay. So eventually the behavior is like it's coming to the point where it is starting. Okay. Is the question clear to all of you? Thangeshwaran?
Yes, sir.
Yes, sir.
Yeah. So what do you
Clear.
think?
Yes.
Okay. So I'm writing the next question. So this is an exercise. See, and this is a correct option. Okay. So just think why. I have drawn the picture. Yeah. So the third question is interesting. Let's say omega is a domain. Domain, an open connected subset, right? And not exercise. I have discussed enough. So it is correct. Omega is a domain and omega prime is it some subset. This is given in the question, which is also a domain. Okay. Not domain, but yeah, okay, let's take domain only. Then it says if gamma 1 and gamma 2 are two homotopic curves in omega, then does the same hold for omega prime. So the question is, if there are homotopy, this question will show that homotopy is a domain dependent phenomena. That is, there can be two curve which is homotopy in one set of domain but not in another domain. Are you getting my point? Okay. So let's see this. So just choose your gamma 1 we saw in the part 1. Okay. Gamma 1 to be the Z uh, centered at 10 units. So this we saw in the first part, right? Gamma 1. It's a unit circle centered at 0, and gamma 2 Z such that mod Z equal to 1. This is a unit circle centered at 0. And we have seen that we have, okay, let's write it like, by part A, so homotopy, we use this symbol gamma 1 and this. Gamma 1 is homotopic to gamma 2 in C, right? Is this correct?
Yes.
Yes.
Yes, thank you. Now my claim is gamma 1 is not homotopic to gamma 2 in C minus 0. So those who have seen the first part, so I told you, just imagine this first circle gamma 1 running towards gamma 2, right? This was the intuition. Geometric picture was this, right? Just give me a yes or
Yes,
no.
sir.
Yes,
Yes,
sir.
sir.
Now, if what if you remove 0? Can it cross? Can it reach to gamma 2? Just imagine. So, like, so at some point, it will come here, right? But at one point when it will be near 0, it one part will be stuck, right?
Yes,
Yes,
sir.
sir.
No, I am just giving you the intuition, like mathematical intuition, why this should not be true. I will write the reason.
Okay.
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 So imagine, this first circle, okay, you imagine you have two. Okay, this is a very silly example, but I think it will work. Imagine this is two bangles. Okay, this gamma 1 is one bangle and gamma 2 is another bangle. Okay.
Okay, sir.
Okay, sir.
Now, and they are placed on the wall, so in a such a way, like, like, you can, so if there is no nail in the center of gamma 1, in the first bangle, it can cross and reach to gamma 2, right?
Yes.
Yes.
But what if there is a nail in the wall where gamma 1 is located? Then you cannot cross, right, after a certain stage, because one end will be stuck.
Mm.
Mm.
Okay.
Okay.
Yeah, because when you will try to move your bangle in this direction, so they will come. So, okay. Because I do actually have one bangle, okay. So this is one bangle, okay. Is this visible to all of you? Now
Yes.
imagine
Yes.
this being a nail. So it will be stuck, right? It won't be able to move after a certain time. But
Yes.
Yes.
if there is no nail, then you can always cross it to reach to the circle, right? Is this clear? But when there is a nail, you cannot do.
Okay.
Okay.
I don't know. I just explained it in a very vague sense, but okay. I, first of all, see, math is all about intuition, right? First of all, you have to develop intuition. So let's see why not. So you remember this result, right? If two curves are homotopic, then the integration of any function which are analytic, that will be same, right? No, what I'm trying to say, if gamma 1 and gamma 2 are homotopic in C minus 0, then this will hold, right? Cauchy's theorem, you must have seen, for every holomorphic function f in C minus 0. You must have seen this in class, right? Yes. Now, what if you choose your fz equal to 1 by z? 1 by z is holomorphic in C minus 0, right? It is, so we denote it by h of something, okay? H of C minus 0, which means holomorphic. H stands for holomorphic. Now, what is gamma 1 dz by z? This we have done enough time. Gamma 1 is, gamma 1 is this circle centered
Yes.
at 10. But 0 is here, yeah? So because 0 is the only singularity for this function, right? So it should be 0, because that singularity does not lie in gamma 1, right? Yes or no?
Sir,
Huh?
yes, sir. Outside the circle.
Yes, yes, okay. Because if a function is analytic inside and on the curve, on a closed curve, then its integration is 0, right?
Yes.
Yes. So this 1 by z, it is holomorphic on gamma. It is, the only problem point is z equal to 0. And z equal to 0 does not lie on gamma 1, neither inside the interior of gamma 1. So 1 by z is holomorphic inside and on the curve gamma 1. Hence its integration is 0. And what about gamma 2? Remember, gamma 2 is this curve, the unit circle, the famous unit circle. Now and we have seen this many a times that it is 2 pi iota, right?
Yes.
So it is a contradiction, right? Because if gamma 1 and gamma 2 are homotopic in C minus 0, then it will imply 0 equal to 2 pi iota, which is not true. Is this clear?
Yes, sir.
Okay. Okay. So this you should be able to answer this question. Homotopy preserves the length of the curve. Is this right or wrong? Does homotopy preserves the length of the curve? So let me give, so any closed curve. Okay. For example, this small circle and this bigger circle, they are homotopic, right? They have same center, because you can always stretch it, right? What do you want in homotopy? You want a curve, right? Like which homo continuous deformation. You have heard of this term? Have you heard of this term, continuous deformation, in your homotopy class? Hello. Okay, what do we mean? Like if two curves are homotopic, okay, let us say, what does this mean? That is, the question is, if two curves are homotopic in some domain omega, because now we know that domain is a very important thing when we are deciding whether or not two curves are homotopic. Then does this imply then length of gamma 1 is same as length of gamma 2? Can we say that? See, if you have, if for example, if you take this circle, let's say this is gamma 1 and this is gamma 2, they are homotopic, right? In C, they are homotopic in C. C is a convex domain, and any two closed curve in convex domain, they are homotopic, right?
Yes,
Hello?
sir.
Yes,
But
sir. But
length is
length
not
is not
same.
same.
Length is not same, right? So this option is
No.
not true. And anyway, when you are using homotopy, what you are using, you are, you can always increase or decrease, right? Like the size, so it will automatically change the length. And there are curves which are homotopic to a point. This much you agree? Null homotopy you have heard. There are curves in the complex plane which are homotopic to a point. So what is the length of a point? It is zero, right? The length of a point is zero. And any non-trivial curve which is not a point, which is homotopic to this point, will it have a zero length? Will it have a zero length?
No, sir.
No, sir.
No. So this is clearly a vague. I mean, this is not true. So now the question is, if gamma 1 is homotopic to sigma 1, if gamma 2 is homotopic to sigma 2, and where this gamma 1 and sigma 1, they are from AB to some omega, these are gamma 1 and gamma sigma 1, they are two curves defined on AB, or a reparameter or a parameterization we can say, such that, so if this is my gamma, oh, okay, such that gamma 1a is gamma 2, oh, gamma 1b is gamma 2c, and same holds for sigma 1, sigma 1b is sigma 1 sigma 2c. Then the question is, is the curve gamma 1 plus gamma 2 is homotopic to sigma 1 to sigma 2? Is it true? What do you think is should be the answer? Okay, let us draw. See, the good thing about maths is wherever you can draw, you draw. So gamma 1 is this curve, okay? Is this visible to all of you? This, or should I magnify it?
Yes, sir.
Yes, sir.
Visible.
Visible.
So this is my gamma 1. Okay, let it be gamma 1. And then where it stops, gamma 1b stops here, right? So gamma 2 starts. Okay, this is going too far. Okay, let's say this is some curve. This is my gamma 2. Now, so sigma 1 is somewhere here that I don't know, like I mean some curve, okay? So this is my sigma 1, and then where sigma 1 stopped, sigma 2 starts. So it's again some curve, sigma 2, right? So we have this thing. Now gamma 1 and sigma 1, they are homotopic, which means you can continuously deform gamma 1 to sigma 1 to gamma 1, right? This only means that, right? Yes or no?
Yes.
Yes.
And same holds for gamma 2 and gamma 1, gamma 2 and sigma 2. So what do you think? As the two, so those two curve gamma 1 plus gamma 2 and sigma 1 plus sigma 2, will they be homotopic? What should be the answer?
Yes.
Yes.
Yes, exactly. Why? Because in the first half you use the map. Let's say here you have map h1 and here you have map h2. Then you
H2.
just add, then you just branch these two map, right? In the first half, you know what I'm trying to say, right? So
Yes, sir.
Yes, sir.
you can explicitly write the map as, okay, so like, so what will be h of s of t? It will be h1 s of t, or 2t, when so h should be a map from 0 1 to 0 1 to omega. So, and something like, like 1 minus s, oh sorry, something you must have seen, right, in concatenation, and by picture it should be clear. So shall I leave this up to you? Hello?
Yes,
Yes,
sir.
sir.
Okay. Now the next question is, okay, so we have almost discussed the main part of this assignment. So Thangeshwaran, you have been present in the last assignment session also, right? I think he's okay. I'll ask him later.
Yes,
Yes,
sir.
sir.
Okay, so the question is, if gamma is a closed curve in C or in some domain omega, it's not satisfy omega is a domain or not, and f belongs to h of omega. So remember, h of omega, space of all functions holomorphic on omega. Okay, I'm using this simple notation, space of all functions. Whenever I write f belongs to h omega, it means f is holomorphic on omega. Space of all functions holomorphic on omega, and this is a very standard term. Okay, then f omega is 0. Is this true? Is this true?
Yes, sir.
Yes, sir. True, sir.
No, but yeah, close curve. But we have seen one example, right? Omega is not like, okay, no. If you choose your omega to be, let's say, some b0, let's say b02. What is b? Okay, let me write. If you choose your omega to be z, all those z such that mod z is less than 2, and gamma to be the, let's say, unit circle z such that mod z equal to 1. So gamma is a subset of omega, yes or no? Gamma is so omega is,
Yes.
Yes.
omega is this radius 2 circle. So radius 2 circle, it's a domain. So boundary, I have not included the boundary, and somewhere here you have your gamma. Okay. Now f is analytic in omega if I define fz to be 1 by z. Yes or no? Oh wait, omega and z not equal to 0. Yeah. So this part is not there. Okay. So f is analytic inside omega, because the only point of problem, the only point where this function is not well defined is z equal to 0, and I have not included that in the domain. All of you agree? Okay.
Yes.
Yes.
And what is f gamma here? It will be dz by z, this unit circle, right? And what is it? It is 2 pi iota, which is not equal to 0. Thangeshwaran, is this clear?
Sir,
Sir,
clear, sir.
clear, sir.
Yes. So whenever you have these examples, like, just keep these examples in mind. 1 by z always. To try any statement, just first of all use 1 by z as the litmus test. So next question is, if gamma 1 is the unit circle centered at 10 and gamma 2 is the unit circle centered at 0 and radius 1, then gamma 1 is homotopic to gamma 2 in C minus 0. Is this true? Is this true? We have seen this, right? The question is, sorry, the question is they are not homotopic. Yeah. We have seen earlier, right? This part,
Yes.
Yes.
that they are not, this is not true. So yeah. So this option, as an option, this is true, right? They are not null homotopic. See, if you have any doubt, any one of you, then just please stop me and ask. If f is holomorphic on omega, and gamma is some curve such that integration of f over gamma is 0, then does this imply gamma is null homotopic? Does this imply gamma is null homotopic? So you just choose again gamma to be the unit disk centered at 0, centered at z equal to 0, and your fz to be 1 by z square minus this point. So it is unit disk centered at 0 minus 0. Okay. And gamma to be the unit circle. Gamma to be the unit circle. Okay. Or let's take some. Okay. Let us take some bigger disk. Z such that mod z is 2 and z is not equal to 0. So again, I am going to ask some question. If f, so is f holomorphic? Is 1 by z square holomorphic on omega? What is the problem point for 1 by z square? Hello?
Z is equal
Is
to
equal to
0.
0.
Yes. 0. Is 0 in the domain?
0
0
not in the
not in the
domain.
domain.
Okay. Yes. Thank you. So it is holomorphic, right? So now is gamma
A
null?
A
option,
option.
sir,
Huh?
A
Sir, A
option
option
also
also
0
0
not in the
not in the
domain.
domain.
Sorry?
A
A
option.
option.
Unit
Unit
circle, sir.
circle, sir.
Gamma
Gamma
unit
unit
circle. So
circle. So
it
it
is
is
It is in
unit
the
unit.
domain, right? This is precisely the domain.
Okay.
So 1 upon z square is not holomorphic on unit circle.
Why?
At 0,
But is on the unit circle is zero, does zero lie on the unit circle?
no, on the unit circle.
Yeah. So we can take integration gamma dz by z square, right? You people seem confused. Tell me, where is the confusion?
Yes, sir. Okay, sir. Okay, sir. Inside, and that is inside the circle. A option. C
Zero is
option
inside the
boundary.
circle. The
Yeah.
only problem point is the 0 point, and we have not included that point in the domain.
Okay, sir. Okay.
So f has no problem in omega, right? Oh, sorry. It should be less than equal to.
Uh, that not is equal to 0 is not there, sir.
No. So okay, let me draw a good picture. Okay. So okay. So this is my what should I call it? This is my disk, open disk. Okay, of radius 2. So just a minute. So the boundary is not included. The center is 0 and the radius is 2. Is this fine? Is this picture clear? Now, now what we are doing? We are removing this point 0. We are not including this. So this is my omega. Is the definition of omega clear?
Yes.
Now, now is the function 1 upon z square holomorphic inside omega? Inside
Yes.
omega, which means 0 is
Yes,
not
sir.
there. Okay.
Then integral value is equal to 0.
Huh? Sorry, Thangeshwaran, please repeat.
Then the integral value is equal to 0.
No. Why?
Sorry.
And I'll come to that. And gamma is here, right? This is 1. Is the gamma clear?
Yes.
Now,
Yes, sir.
Thangeshwaran, what you are saying is when you are saying, like this dz by z square is 0 on omega. No, because the point of singularity lies in the interior of omega, right?
Yes.
Yes, sir.
So it is not 0. What you are trying to use is something else. So just read the theorems carefully. Now, if you
Okay,
convert
sir.
it in the polar coordinates, what it should be? If you put z equal to e iota t. So t going from 0 to 2 pi, do you agree?
Yes, sir.
Yes.
2 pi
Yes.
And dz will be
e power,
iota. So
e power
iota,
minus 280
yes, dt
uh,
by e iota t 2 time.
280.
Again, Thangeshwaran, it will come 0, but not by your logic. Okay.
Okay, sir.
So t equal to 0 to 2 pi. So it will iota I can push out and it will become e minus iota t dt. Am I correct?
Yes, sir.
And what is the integration of exponential? It will be this. Do you agree?
Yes, sir.
So can I say because it is iota times e minus iota 2 pi by minus iota minus e0 by minus iota. So they are same, right? So it should be 0. This is 0, right?
Yes,
Yes,
sir.
Yes,
sir.
sir.
Now tell me, is gamma null homotopic in omega? Is gamma null homotopic in omega? Null homotopic, what does null homotopic mean? You can bring it to a point. You can shrink it so much that it can be boiled down to a point. So for example, if you have a plate with no gap, with no hole, okay, then imagine it is like super stretchable material, like, so you can shrink it, right? Like, because there is interior part, so you can shrink it to a point, right? See, what does null homotopic mean? You can change your curve, which by change we mean continuous deformation. So your curve can be continuously deformed to a point. If it is not possible, then it is not null homotopic. So can you bring your circle to a point? Is circle null homotopic to a point? First of all, my question. Is the question clear? Let's say if circle, if okay, let's say we have proved that gamma is not null homotopic, then we are done, right? With this option. Because f is holomorphic on omega and integration of f over gamma is 0, but gamma is not null homotopic. Then this option is false, right? Yes or no? Say something. Oh, am I not audible?
Sir,
Sir,
audible.
audible.
Okay. So my claim is gamma is not null homotopic. Gamma is not null homotopic in omega. And this is clear, right? This we have seen. If it is null homotopic, if it is null homotopic, then like this will happen, right? Okay, we have used f. It will be same as some point, right? Let's say z naught. This will be same as this for every g holomorphic in omega. Yes or no? Yes or no? This is Cauchy's theorem. If two curves are homotopic, then their integral value will be same.
Yes, sir.
Yes, sir.
So if you're integrating over a constant, then what should be the answer? If you are integrating over a constant value, it should be 0, right?
Yes,
Ah,
sir.
yes, sir.
0.
Zero.
Yeah. But does LHS will be 0 always for all curve? For example, we have seen this now the third time we are seeing. This value is not 0, right? This is 2 pi iota. Yes or no? If it is null homotopic, okay, let's start from the beginning. We have to prove that unit circle is not null homotopic in gamma. If it is, let if possible it is, then this integration over gamma of g will be same as integration of constant over constant of g for every holomorphic function g in omega. Now you take, we know that RHS will always be 0 because integrating over a constant, it will give you 0. Now, when you are integrating over gamma, this dz by z does not give you a 0 value, right? We have seen this. Yes or no? If,
Sir,
see,
not
Not
audible.
audible.
am I not audible? Am I audible?
Yes, sir.
Yes, sir.
So, Darshan, is this clear?
Yes,
Yes,
sir.
sir.
So if it is not clear, then just stop me, okay? Otherwise, I have no option to assume that okay, it is clear to all of you, okay? So this option is false. So this option is false.
But sir,
But sir,
can we
can we
integrate
integrate
over
over
fixed
fixed
point
point
Z0?
Z0?
Is it
Is it
possible?
possible?
You just apply the value. So what is integration? So in the Riemann sense, what is integration? The area under the curve, right?
Yes.
Yes.
So
So under the point, what will be the area? It will be just a line segment, right?
yes,
Yes,
line
line
So
segment.
what
segment.
is the area of a line? It is zero. It has some length, but to have some area, you have to have some breadth also, right?
Yes.
Yes.
So
It's
trivially
zero,
it is
sir.
zero.
So
Trivially
So
it is
how
how
fine.
we
we
say
say
zero?
zero?
That is what I'm trying to make you understand. Like integrating over a point, it will always give you zero value. Okay. Let's start from the basic. When you learn Riemann integration theory, or in your class 12, what does integration mean there? Because everything is generalization of that, right? So if you have some curve, okay, and I ask you to integrate over this integral, what will it be? It will be the area under this curve, right? The
Yes,
integration.
sir.
Yes,
Then
sir.
it is
Yes.
Yes.
so this FAB, this will be area under the curve, right?
Under the
Under the
curve.
curve.
Yeah.
Yes.
Yes.
Now, if I just give you one point, let's say X, what will be the area? I can always also consider this X to X, right? No one has stopped me. See, if you go back to your books, and you will find that most of the time it is written A is not equal to B when defining an interval.
Yes.
Yes.
Because one approach is, because otherwise it will be a point, and area under a point, it should be zero, right? Because by this logic, it should be area under the point, this area of this line, right? And does this line
Yes.
Yes.
have any area?
Yes.
Yes.
Line.
Line. Uh,
Line has length, line has some length,
Length and
Length and
breadth.
breadth.
but
And
it has no
some
breadth,
Some
na?
breadth.
Does it have any breadth? So for area, for example, if you're calculating area of square, what is the formula? Length into breadth, right?
yes.
Yes.
So this line is like a square with breadth zero, right?
Hmm.
Hmm.
So it should be zero,
Uh,
right?
Sir, a
Sir, a
line
line
can
can
have
have
only
only
length.
length.
It can't have
Can't have
area.
area.
It can't have breadth means it does not. It has breadth zero, right? We are discussing something very what should I say? Uh, Vague mathematical terms in some sense. But still, if you have doubt, then please tell. Is this clear why the integration over a point should be zero?
Yes.
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 Sir, clear,
And
clear,
even
sir.
Clear, sir.
so, this
Yes,
is
sir,
this
Yes,
is
sir.
clear,
the
sir.
Clear, sir.
Clear, sir.
okay. So this is the idea. And when you jump to the complex function theory, it is nothing but generalization of the Riemann theory. Okay, because
Yes,
what
sir.
Yes,
what
sir.
what will be this gz dz? It will be g e iota t. Iota you can go out, and this will be e iota t dt. And this t will be a fixed number, right? A to a, because it is a point. And now all these are, and like this is now some valid complex number integration. Then it will have some u plus iota v, real part and complex part. So it will be t a to a u dt iota times v dt, and this becomes the real Riemann integration, right? So it will be 0 plus iota 0, which will be 0. Yes or no? So
Yes,
the
sir.
the
Yes,
thing
sir.
is very easy. Okay. Now the third question. So now all are short questions. Okay. So we have to integrate this dz by 1 plus z square over the curve mod z equal to 2. So is this clear? The question.
Yes,
So this mod z square plus 1, okay, it can be written as z plus iota
into
z
Z
minus
minus
1,
iota.
right? Now tell me, can I write it as z minus iota minus z plus iota 1 upon 2 iota? Oh. Can I write this? Because when you solve this, what it should be, z minus iota, z plus iota, then z plus iota minus of z minus minus plus of iota, right? So it will cancel out and then it will be 2 iota. But we have divided by 2 iota, so it will also cancel out and only this thing will remain. Is this clear?
Yes, sir. Clear, sir.
So now can I say that integrating this thing dz by z square plus 1, it is same as 1 upon 2 iota dz upon z minus iota minus 1 upon 2 iota mod z equal to 2. This is same as this, right?
Yes,
Yes,
sir.
sir.
So do you remember the integration? So what will be its value? So
Uh,
mod
2
z,
pi.
exactly, thank you. But let's see how. Okay. Okay. So okay, let's copy this picture. So we have the same picture, but something has to be done. Yeah. So why it should be 2 pi iota? So now this is my mod z equal to 2. And where, so the only singularities are iota in the first part and in the second part. So someone please mute their mic. Yeah, minus iota. So integrate. Okay, so let it call I1. So what is I1? I1 is dz upon z minus iota mod z equal to 2. So you can show, like, like it will be 2 pi iota. Okay, and it's the same as we show, for example, when we use the dz by z. Okay, so what you can do, you can actually put this, okay, z minus iota to be w. Okay, so then dz will be dw. Yes or no?
Yes, sir.
Yes, sir.
And because mod z equal to 2, so it will be mod w plus iota equal to 2. Right or wrong?
Right,
So
sir.
Right, sir.
so this I1 will become mod w plus iota equal to 2 dw by w. Right? Yes or no?
Yes, sir.
Yes, sir.
Okay, now dw plus iota, which means centered. Oh, I have done some horrible mistake. You people don't tell me. Yeah. So with centered at minus iota, and so this is my let's say this is gamma 1. So this is my gamma 1, right?